Hello, welcome back. I'm Ryan. Today I'll be talking about sum and product of roots. So the idea of sum and product of roots is used to find the roots of a polynomial function. So as we can see in here, this is a quadratic equation, a general way of writing quadratic equation when we're trying to find the roots because when we take a look of quadratic equation like this, not sometimes. And what it means by roots is when the function is having an intercept or touching the x coordinate, which is this 2 point, and this 2 point is when y is equals to 0, which is why here is equals to 0. So what are the ways of finding the roots of a quadratic equation? So the first way is factorize. So for example, there will be x times x plus 2 maybe, and that's equals to 0. And when x is equals to 0, the value will be equals to 0 in here. So that would be one of the root. And when x is equals to -2 in here, the y value will be 0 again. So that's why those two are the roots. And a second way is using quadratic equation. I think most people are familiar with it because it's quite popular to use. So it will be x equals -b plus minus square root b squared minus 4ac divided by 2a. So I'm noticing b, a, and c, they're all constant. So the third way will be completing the square. So for example, x squared plus 2x plus 1 is equals to 0. And we can change this form into square, like x plus 1 square is equals to 0. So x squared plus 1 square is equals x squared plus 2x plus 1. They're the same, but just different form of expressing in mathematics. So when x is equals to -1, the y value at this point will be 0, which is the interception of on x coordinate, which should be which should look like this here. Okay, this will be 1, and this will be -1, x coordinate, y coordinate. So that would be the intersection point. So when we want to find the roots, we want to change it into a different form compared with here. So we can change it into x minus a constant, we call it alpha, and x minus beta, that's also a constant, and that's equals to 0. So that's equals 0, but it can also be equals to ax squared plus bx plus c, because it's just a different form of expressing, just like the idea in here. So x squared plus 2x plus 1 is equals to x plus 1 times x plus 1. They're the same thing, just different expression. So when we look at here, no matter how we expand or switch the position of the coefficient, we still won't be able to get from here to here because there's a constant a in front of here. So all we need to do is just times a in there, and they should be the same. So we want to expand it now. So x times x is x squared, x times beta is negative x beta, x times beta, and negative alpha times x is negative x times alpha, and negative alpha times negative beta is plus alpha times beta. That's equals to x squared plus b, x plus c. And we want to group the like terms together because that's just how mathematicians like, because they're lazy. So there's an x and x, so there will be like terms here. So that will be a times x squared minus x beta plus alpha times beta, and that's equals to ax squared plus bx plus c again. And we expand the brackets, ax squared minus ax beta plus alpha plus a alpha beta is equal to ax squared plus bx plus c. So looking from here, it seems like we're done, but we can actually connect the left hand side with the right hand side, like finding some relationship. So notice on b here, on bx is equals to negative ax times bracket beta plus alpha, and a times alpha beta is equals to c. So we can write it into a relationship of negative ax beta plus alpha is equals to bx, and the second relationship can be a alpha times beta is equals to c. So what we mean by the sum of roots and product of roots is sum means plus, and that would be here plus. So the whole thing is called sum of roots, which is here, and product means multiply, which is timesing, which is here. Then those are the sum and products of roots. So I want to put it in this as the main subject. So here, negative a beta plus alpha is equals to b, and b divided by a times negative is equals to beta plus alpha. This is the sum of roots. We're going to put it down first. And in here, we can express it as c divided by a is equals to alpha beta, which is what we call product of roots. So thank you very much for watching, and this will be the sum of roots and product of roots proving of where they come from.